Okay, hi everyone. Today we're going to work on multiplying and dividing radical expressions. So I have this chart to help us out. There's some similarities and some differences between when we do both of these. So when you multiply radicals, you're going to want to be able to multiply like radicals. Now what I mean by that is they have to have the same index. So cube roots with cube roots, fourth roots with fourth roots, things like that. Okay. You're going to multiply the numbers and add your exponents and stuff like that first. So you're going to multiply first. Then simplify. I just find that to be easier, because sometimes you can simplify and then multiply, but then you end up simplifying again. And when we multiply, you want to multiply your numbers with numbers. And your variables with variables. Okay? And then you're going to simplify like we did the other day. Now with quotients, unlike multiplying where you're going to multiply first, then simplify, for quotients or dividing, you're going to simplify first. Okay, now what I mean by that is that you're going to simplify up and down. So think of it as reducing the fraction, and it's going to make your life so much easier. And again, we have to do with like radicals. Okay, so radicals with radicals. So we want to make sure that it's like the square root, cube roots with cube roots. Okay, all right, and then we're going to do what is called rationalizing the denominator. And we're going to spend a little bit more time on that in a few minutes. Basically, that means you cannot have a radical in the denominator of fraction. Okay? All right, so let's try a couple of these. We'll start with multiplying. So remember, we're going to multiply and then we're going to simplify. So when we multiply these two together, we get the square root of 100, which is just 10. So that's not too bad. All right, let's try these two. So multiply those two together, or you can simplify. This one you probably would be easier doing it this way. Okay, sometimes there's always exceptions to the thought. Okay, but here we can't do it. There's no solution to this multiplication because one is a fourth root and one is a square root. So we can't do it right now. Well, we are going to fix that problem later on, but right now we're going to say no solution. All right, so let's try this one. It's a little bit more complicated. All right, so we have both our cube roots, and we're going to multiply the 50 and the 15. Okay, so we're going to get the cube root of 750. Okay, multiply your variables. And now we're going to do what we did the other day. Break down 750 and then do the cube root of x squared, the cube root of y cubed, and the cube root of z to the 6th. Okay, so let's break down 750. Okay, I'm going to do 75 and 10. You can pick any pair of numbers you would like. So I got 3 and 25, 5 and 5. 10 is 5 and 2. And remember, because we're looking for a cube root, we're looking for a group of 3. So here it is. So those are going to get multiplied together, and we get 125. So the cube root of 125. And this cube root of 6. We're going to take the two guys that are not pairs and multiply them together. All right, so let's do our variables. Let's move this guy out of the way. Okay, so let's do our variables. The cube root of x squared, well, 3 doesn't go into 2, so we're going to leave him as the cube root of x squared. 3 goes into 3 once. 3 goes into 6 twice. All right, so let's bring them all together. The cube root of 125 is 5y z squared, cube root of 6x squared. Okay. All right, so let's try this one. Now this one has numbers out in front, which we're going to multiply together as well. So we have negative 6 cube root of negative 108 x to the third y to the fifth. All right, so let's bring negative 108 on the side. Now notice that negative 6 is just kind of hanging out there. All right, so let's break that down. I'm going to use the 9 and the 12. Okay, and again, we're looking for a cube root. So this is 4 and 3. This is 2 and 2. This is negative 3 and 3. So my pairs, my group of 3 is 3. So we have the negative 6 cube root of negative 27. And then remember that the guys who have no group of 3, that's these two, are going to get multiplied together. Okay. Now I'm going to do my variables. Remember, we're going to do 3 into 3 goes once. 3 into 5 goes once with 2 left over, so they stay underneath the radical. All right, so we have the cube root of negative 27 is negative 3, and that's going to get multiplied with the negative 6 that's out in front. And we have an xy cube root of 4y squared. Okay, so let's multiply the 6 and the 3. We get 18xy, negative 18, cube root of 4y squared. Okay. All right, so let's try division. All right, so this is when we said we're going to simplify first before we take a look at this. So let's simplify this, see if our life becomes easier. So because they're both square roots, we can do 75 divided by 3, goes in nicely. We get the square root of 25, which gives us an answer of 5. Trust me, not all of them are that simple. Let's try this one. Okay, so we're going to do 63 and 7. So numbers with numbers, variables with variables. That's how it's got to work. So we have the square root of 9x, subtract your exponents, remember that's what we do when we divide, y squared, and then simplify it. Cube root of square root of 9 is 3. Can't do anything with the x, and then the square root of y squared is y. All right, let's try one more. Okay, simplify up and down first. So 54 divided by 2. I want to say that's 27. It is, all right. So the square root of 27, subtract your exponents. Okay, now we got to simplify 27. Okay, so on the side. Now after a while, you'll know certain roots off the top of your head because they show up a lot. So 27, we get the square root of 9, square root of 3. Do your variables, we get x, square root of x, and y, because square root of y squared is y. Okay, so we get 3xy, square root of 3x. All right, so we should be okay on our multiplying and simple dividing. The problem is that when we do division and we still have a radical on the bottom of the fraction. All right, so what we do, what does it mean to rationalize the denominator? This means that we're going to eliminate the radical in the denominator. From the fraction. Okay, so we're going to kind of just take it and we're going to fix the problem, or we're going to take care of it so that there's no more radical in the bottom of the fraction. Okay, so I have some steps for us to try and help us make this a little easier process. So step one, we're going to simplify the radical as best we can. So simplifying up and down like we did in the previous problems. So we're going to want to simplify the radical. Now, step 2 is we're going to take care of this radical. So what we want to do is create an equivalent fraction by multiplying the numerator and denominator by what's going to make the denominator, whatever's in the radical, a perfect root. So we're going to multiply the denominator and numerator by what makes the denominator a perfect root. Okay, now you'll see what I mean by this in a minute, so just kind of be patient. Okay, now in step 3, we're going to simplify again. Okay, now when you're done simplifying here, the final answer should not contain any roots in the denominator. Now the numerator, sorry, not getting any love. He really doesn't, he can have as many roots or cube roots or whatever he has. He can have anything in the numerator. We just can't have a radical in the denominator. Okay. It's kind of like bad math, bad form. It's like polishing your sentence when you write an essay. It's not wrong, but it's not right. Okay, so it should not contain any roots, any radicals in the denominator. Okay, so the key is to trying to make these numbers as small as we possibly can, and the variables with less exponents if we simplify first. All right, so in this problem, we're not going to be able to simplify because y doesn't get divided by 5. So the first question is what do I need to multiply 5 by to make it a perfect? Well, this is a square root, so you need to figure out what do I need to multiply 5 by to make it a perfect square. Well, that's 5. So we're going to multiply top and bottom by the square root of 5. Now, we're going to multiply straight across, and they're both square roots, so we can do that. So we get the square root of 5y over the square root of 25. Simplify again, square root of 5y over 5, and that's where we're going to leave it. Do not reduce the 5 into 5 because one's underneath the square root sign and one is not. So you're not allowed. They're totally different numbers. One's irrational, one's rational, and they don't play well in the sandbox. All right, let's try this one. Now again, we're going to try and make our lives easier here by simplifying. So if you look, they're both cube roots, and I have a 2 in the numerator and a 4 in the denominator. So let's simplify this and reduce that 2 over 4 to 1/2, or just the square root of 2 on the bottom, or the cube root. Now I'm going to take a look at this and say, hey, what do I need to multiply 2 by to become a perfect root? Well, I want it to be a perfect cube. Well, 2's perfect cubed is 8. What do I need to multiply 2 by to get to 8? That would be 4. So I need to multiply top and bottom by the cube root of 4. Again, we're going to multiply straight across. Okay, so that's going to be the cube root of 4x over the cube root of 8. And now we get the cube root of 4x over 2. And again, don't reduce the 2 into 4 because the 2 is an integer, the 4 is irrational. Okay, so let's try these two. Again, simplify up and down to make our lives easier. So 8 and 2 gives us 4. Okay, a, so I get the cube root of a on the denominator, and b to the 4th, and b gives me b cubed. All right, so let's take a look. What do I need to multiply a by to be a perfect cube? Well, there's 1a, it's going to be a squared. So I'm going to multiply top and bottom by the cube root of a squared. Multiply straight across. Okay, now I'm going to simplify. Now if I look, the top, we do have a b cubed, so I'm going to simplify him to b, cube root of 4a squared, all over a. And that's as far as you can take it. All right, let's do one more and then we'll call it a day. All right, simplify 128 and 24. I do believe they're both divisible by 3. So that's going to give me 4. No, wait, I'm sorry. They're not divisible by 3. Divisible by 8. My apologies. So we get the 4th root of 16 over the 4th root of 3. Let's do our variables. So I have an x in the bottom, and I have a y to the 4th. All right. Now, y is already a perfect 4th, so I don't need to take care of him. But I do need to multiply. What am I going to multiply 3 by to make him a perfect 4? Well, I need 3 more 3's. So that's going to be 27. And I need 3 more x's. Okay, multiply straight across. Oh, we can even simplify 16 too. Let's take this 16 and make him a 2. Make our lives easier there. So 2 4th roots of 27x cubed in the numerator. And then in the denominator, we're going to get the 4th root of 81 x to the 4th, y to the 4th. Okay, so let's simplify that. We're going to get 2 4th roots of 27 x to the 3rd over 4th root of 81 is 3 x y. All right, please let me know if you have any questions, guys. Otherwise, I'll talk to you soon.